My name is Claire Herding. I'm a postdoctoral fellow in the Laredo lab at the Whitehead Institute. I work on toxoplasma.
So toxoplasma is a parasite and has to replicate inside a mammalian cell. So it will swim through the tissue until it finds a cell, it will then attach, reorient itself and invade through a tiny constriction. Once it's inside the cell, it will replicate many times, forming these beautiful flower-like vacuoles until finally it's ready to burst out of the cell, killing the human cell, and each individual parasite going on to find new cells to infect. Although toxin infection is very common, in the vast majority of people it causes no symptoms, and in those it does, very effective drugs are available.
So one of the really exciting things about toxoplasma is that we know so little about it. We have no idea what more than 60% of the genes do, and only a vague idea what the other 40% do. By studying toxoplasma and the way that it interacts with our own cells, we can actually learn new facets of how our cells behave, especially with regards to pathogens. And this can tell us a lot about both the normal metabolism of our cells and how it changes in infection.
So in this image, we can see a single human cell infected with hundreds of parasites. So we can see the human cell nucleus in blue here, the skeleton of the human cell in red, and in white outlines each individual parasite. And in these bottom ones here, you can see the parasites are starting to divide. So two daughter cells are forming. These will elongate and eventually burst out of the mother, killing the mother cell.
Because two daughters emerge from each mother, they tend to grow like this, forming petals of a flower. So I'm very interested in this protein here that's outlined in white, called GAPM1A.
Which goes to the periphery of the parasites. And I've found that this protein is essential in maintaining the shape of the beautiful shape that we can see here. When we remove GAPM1A, the cells quickly collapse and form these large undifferentiated masses, which can no longer escape from the host cells and no longer go on to form productive infection. So this tells us that the interaction between GAPM1A and the underlying cytoskeleton are really important in maintaining the viability of the parasites and its ability to cause disease. By studying GAPM1A, we gain a better understanding of these peripheral structures, and these structures are found in many different organisms, most of which are completely unstudied.
One of the most important things you need as a scientist is resilience. Most days, things don't work exactly as you expect, or experiments go wrong. It can be really challenging to do science every day. But sometimes when you find something new, when you confirm something that you expected, when everything works perfectly, it's incredibly rewarding to be able to discover something new about nature that no one else has ever seen before.
Is it true?
I think so.
All right.
I'm doing some experiments. I'm going to write it and put it on the internet, and then it will be true. Yeah, that will save so much time.
There's so much more sympathy for actors now. They know their lines. I don't.